if it doesn't give you an interval, okay? If you have no interval, then things change again, okay? And the reason that things change is because you're saying, well, I want every angle that has this reference angle and a positive sign, I want it going around the circle an infinite number of times, okay? Which means that as we go around the circle here, okay, let me go to the next page. What we're doing is we're saying, if this is your angle, okay, if this is theta, you don't just want this angle. You also want this angle. So you also want the angle if you go around the circle again. Okay. You also want the angle if you were to keep going. So you want that angle too. These are all the same angle. Okay. So you want that angle too. You want the angle if you were to go around a third time. If you were to go around a fourth time, a fifth time, an infinite number of times. Okay, so in other words, if x equals pi over 4, you also want x equals pi over 4 plus 2 pi. And x equals pi over 4 plus 4 pi. Okay, or pi over 4 plus 2 pi a second time. And you want x equals pi over 4 plus 2 pi a third time. And x equals pi over 4 plus 2 pi a fourth time. Okay, so what do we mean by 2 pi times 2? 2 pi times 3, 2 pi times 4, just as an example. This is 3 rotations around the circle, a fourth rotation around the circle. You want a 5th rotation, a 6th rotation, a 7th rotation, okay? You want all n rotations. So your answer would be, instead of x equals pi over 4, you would have x equals pi over 4 plus 2 pi n times for all of the rotations that you go around the circle, okay? This n is n rotations around the circle. Okay, so that would be your answer. So if there is no interval, then our answer here, instead of just being pi over 4, if we hadn't specified an interval, you would have written pi over 4 plus 2 pi times n. And you would have written 3 pi over 4 plus 2 pi times n. okay? Because you're saying it's pi over 4, but it's also pi over 4 plus 2 pi, plus 2 pi again, plus 2 pi again, plus 2 pi again, n times, okay? And 3 pi over 4, plus 2 pi again, plus 2 pi again, plus 2 pi again. So if there is no interval, then you add 2 pi over n, okay? And I'll also make a note here that it has a parentheses at the end. Because 0 equals 2 pi, or 0 equals 360 degrees. Okay. Sorry, it didn't come out. So let's get to more solving of equations. And we're going to use intervals and no intervals. And as soon as you start doing it, you're going to get accustomed to it. Okay. So let's say that we have so this is our third example. Let's do this one without intervals, okay? And we're going to do everything in radians, okay? Everything is going to be in radians, just because I want you to get really accustomed to it, and you're already accustomed to degrees. So this one, 3 tangent squared x minus 1 equals 0. So if you notice, I'm not saying in the interval. That means that you're going to have to do this addition, okay? So once again, all we do is isolate. So we're going to add 1 to both sides. Okay. So we get 3 tangent squared to x is equal to 1. Now we divide both sides by 3. All of this should be familiar to you, okay? So we get tangent squared to x is equal to 1/3. We need to isolate tangents. We have to take the square root. Now, when we take the square root, remember, you need a plus or minus every time you take the square root. Okay, don't forget the plus or minus. So what does this give us? Tangent of x is equal to plus or minus 1 over the square root of 3. Okay, so square root of 1 is 1. Well, if we go to our, this is the same thing as square root of 3 over 3. Right? If we rationalize our denominator. So, first of all, what quadrants? I'm going to bring this up here. Okay. So we are in quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We're in every quadrant because of this plus or minus. Tangent could be positive or negative. We're in every quadrant. Now we need the reference angle. Well, we're going to go to our exact value chart and we're going to find our reference angle. Square root of 3 over 3. You should know this, okay? I want to show you the exact value chart again because I want you to become familiar with how to use it. So our tangent is square root of 3 over 3, so we're looking inside the chart now, okay? When we're looking for tangent inverse, you're looking inside the chart when you're looking for the angles. So square root of 3 over 3, that's pi over 6. So our reference angle is pi over 6. Okay, so in quadrant 1, don't forget to write x equals. Okay, in quadrant 1, it's pi over 6, and then there is no interval, so we're going to write 2 pi n. In quadrant 2, if you remember, you take pi and you subtract pi over 6. So that would give us 5 pi over 6. Practice with your fractions. And then we'll do plus 2 pi over n. Quadrant 3, that's pi plus pi over 6. Or 7 pi over 6. Plus 2 pi n. And then x equals 2 pi minus pi over 6. And that gives us 11 pi over 6 plus 2 pi n. Okay, so a couple of things here. First thing is, remember that the way that I'm getting 5 pi over 6 is we're multiplying top and bottom by 6 over 6. So we get 6 pi over 6. 6 pi minus pi is 5 pi. This one, it's 6 pi plus pi over 6. 6 pi plus pi is 7 pi. And this one, when we multiply 6 by 2, we get 12 pi over 6. So 12 pi minus pi is 11 pi. Okay? Now here's the thing though. So this is kind of special because we're in all 4 quadrants. And when we're in all 4 quadrants, that makes a difference in our answers. So let's take a look at being in all 4 quadrants. So this is pi over 6. And then we're going to take a look at this. This is also pi over 6, right? Same reference angle. Well, that means that we could also save our, this is quadrant 1. And this is quadrant 3. Well, here's the nice part of this. Okay. The nice part of this is that we don't actually have to identify both of these angles. Because if I can identify this angle here, if I add pi to that angle, then it brings me to the angle in quadrant 3. And if I add pi again, so this is plus pi. If I add pi again, it brings me back to quadrant 1. If I add pi again, it brings me back to quadrant 3. And if I add pi again, it brings me back to quadrant 1. So it turns out that we can actually write this in a different way to save ourselves from having to write all 4 quadrants. We could instead say, well, in quadrant 1 and quadrant 3, we could say x equals pi over 6 plus pi times n. That'll give us the angles in quadrant 1 and quadrant 3. So instead of writing plus 2 pi n, I could take care of the angle in quadrant 3 also by just writing pi plus pi n. Because instead of adding 2 pi and just getting the angles in quadrant 1, I can add pi and then I'll get us the angles in quadrant 2. In quadrant 3. And the same thing is true for quadrant 2 and quadrant 4. Once I find the angle in quadrant 2, I can also find the angle in quadrant 4 in the same way. This is 5 pi over 6 plus pi times n. Okay, and that saves us. We don't have to do the quadrant 3 and quadrant 4 separately. And that's always going to be true. If we have angles in all 4 quadrants, we can put quadrant 1 and quadrant 3 together, and we could put quadrant 2 and quadrant 4 together. Okay. Let's take another example. You don't have to do this, but it does make it much more efficient. Okay? Much more efficient. So let's do another example. Let's do 4 sine squared x minus 3 is equal to 0. And once again, we're not going to give you an interval, but we will say in radians. Everything is in radians. Okay. So once again, we add 3 to both sides. Okay, we're just isolating our trig function. That's what this is about. So we have 4 sine squared x. And sometimes you'll see x, sometimes you'll see theta. Just be consistent that in your final answer, if it's theta, then in your final answer, you're going to write theta equals. We divide both sides by 4. Sine squared x equals 3 over 4. This is sine squared. We have to get rid of the square, so we take square root. And it's plus or minus. Don't forget your plus or minus. Okay. So what do we have? We have sine of x is equal to plus or minus square root of 3 over 4. This is the same thing as plus or minus square root of 3 over 2. Okay, the square root can be distributed. So you have square root of 3 over square root of 4. Square root of 4 is 2. So what quadrants are we working in? We're working in quadrants 1, 2, 3, 4. Okay, because it's plus or minus. When you see a plus or minus, it's all 4 quadrants. And remember, we compare quadrant 1 and 3. Because we're just going to do plus pi n. And we can pair quadrants 2 and 4. We can only pair, so obviously if it weren't plus or minus, there's no quadrants to pair. So now we need our reference angle. Okay, so we're thinking of, well, the sine of what angle is square root of 3 over 2? okay? And if you're familiar, which you should be, it's pi over 3. So our reference angle is pi over 3. Okay? So we really only have to worry about quadrant 1. We don't have to worry about quadrant 3. Okay? We only care about quadrant 1. So in quadrant 1, our x is just pi over 3. But now we have to take care of all of these angles that have this, okay? All of these angles. Going around the circle an infinite number of times. So in order to take care of quadrant 3 also, instead of adding 2 pi n, we're only going to add pi n. Again, this only works when you have a plus or minus, right? If this had just been sign is positive, quadrant 3 wouldn't be here because quadrant 3 has a negative sign. Okay, and we only have to worry about quadrant 2 for the same reason. So quadrant 2, it's not pi over 3, right? It's pi minus pi over 3. Well, that gives us 3 pi over 3 minus pi over 3. Or 2 pi over 3. So what's our answer? 2 pi over 3 plus pi times n. Because we have 2 quadrants to take care of. It's pi times n instead of 2 pi because we also have to get the angle in quadrant 4. So this is our answer. Okay, it's pi n because we're working for angles in 2 quadrants. Okay, quadrant 1 and quadrant 3 and quadrant 2 and quadrant 4. Okay, let's take another one. And this time, okay, let's take another one. And again, for this one, I'm not going to give you an interval. I will give you an interval again, but not yet. Let's take cotangent of x, cosine squared x is equal to 2 cotangent of x. Okay, so this is really different, right? How do we do this? Okay, so when you see 2 different trig functions like this, you want to be careful. You never want to cancel out a trig function. So you never want to get rid of a trig function. And this is really important because by getting rid of a trig function, you lose an answer. So we talked about this in the last lecture. Okay, we talked about this in the last lecture. We said when you verify identities, you only work with one side at a time. This is the reason, okay? If we were to take both sides and cancel out cotangent of x by dividing both sides by cotangent, we actually lose answers to our equation. So we never want to do that, okay? So now the question is, if we don't do that, then how in the world do we solve this? Set it equal to 0. So when you're not sure what to do, this is your go-to. Okay, when you're not sure what to do, that's what you do. So how does that affect this? We subtract 2 cotangent x from both sides. Okay, and what does this give us? Cotangent of x cosine squared x minus 2 cotangent of x is equal to 0. And now we're just saying, okay, how do we solve this? So you certainly can add 2 cotangent of x to both sides, because then you just undo what you did. But if you notice, cotangent of x exists in both terms, so we can factor it out. Okay, so one of the things that you should always be looking for is, can I factor? Okay, and we see 2 different trig functions. That should be something that you think about. Now you can also think about Pythagorean identities, okay, but which is perfectly fine. If you can find a Pythagorean identity to make things work, that's perfectly fine. You can do that. But we don't have a Pythagorean, or at least not a clear Pythagorean identity here. So our option is pull out cotangent of x, factor. Okay, cotangent of x is in both terms, so we pull it out. And what are we left with? Cosine squared x minus 2. And now it doesn't matter that we have 2 different trig functions, because we can use the 0 property. We can set each trig function equal to 0. So either cotangent of x equals 0, or cosine squared x equals 0, or cosine squared x minus 2 is equal to 0. Okay, now we solve each equation. This is the 0 property. Okay. Okay, so we need to figure out where cotangent of x is equal to 0. So we're going to start with that one. And I'm going to put these in red as your 2 separate equations. Okay, we need to figure out where the cotangent of x equals 0. But we don't know cotangent of x, right? We only know sine, cosine, and tangent, but that's okay, because we could take the reciprocal of both sides. And when we take the reciprocal of both sides, the reciprocal of cotangent of x is tangent of x. And the reciprocal of 0 is undefined. So what we're looking for is values of x, okay, where the tangent is undefined. Well, tangent is undefined when cosine of x equals 0. Right? This is what we were talking about with the graphs. Right? This is where your asymptotes are. Tangent is sine over cosine. So when cosine is 0, it's undefined. And where does cosine equal to 0? Okay, well, think back to your unit circle. Let's see if we can find it. Cosine is equal to 0 when x is equal to 0. Well, x is equal to 0 here, okay, and here. If we take this value and we add pi, we get this value. If we add pi again, we get this value. Add pi again, we get this value. So if we find where cosine is equal to here, then we can just add pi times n. So what angle is this? This angle is pi over 2. And then we just add pi times n to get all of the answers. Now you would have lost this answer if you divided both sides by cotangent, okay? If you divided both sides by cotangent over here, you would have gotten rid of the cotangent and this answer would have been lost, okay? So this is the solution to one equation. Now we have to find the solution to the other equation. So our other equation is cosine squared x minus 2 equals 0. Okay. We add 2 to both sides. We get cosine of x is equal to 2. We take the square root of both sides. And you take plus or minus. So we get cosine of x okay, and you're probably sitting there thinking, but that's not in the exact value chart. You're right, it's not. In fact, this is impossible. There is no solution. How do we know there's no solution? It's outside the range of cosine, okay? There is no x value that you could plug in that'll give you plus or minus square root of 2. That's because square root of 2 is greater than 1. And cosine is the number that's less than 1. Okay, so there is no answer. Cosine of x must be less than 1. Square root of 2 is greater than 1. Okay, and the same thing would be true if it's negative, right? Cosine of x has to be greater than negative 1, and negative square root of 2 is is less than negative 1. Okay, so this is outside the range of cosine. So you should pay attention to that. If you don't see it in your exact value chart and you plug it into the calculator and you do cosine inverse and it's outside, it gives you an error, that's because it's outside the range. Okay, so you should always make sure that your cosines are between -1 and 1, and if they're not, then there is no solution. Okay, so if you had done this, it would have looked like there was no solution to this equation, but there is a solution, pi over 2 plus pi n. Okay, so a little tricky there. Okay, let's do another example. This one we'll do with an interval. Let's do 2 sine squared x minus sine of x. And actually, I'm going to use theta for this one. You'll see why in a second. Minus 1 equals 0. Okay, so we look at this and we say, how do we do this? Well, it kind of looks like quadratic, right? So we solve it exactly like a quadratic. Okay, now some of you are, if this were quadratic, right, the first thing that we would do is factor. Now some of you may look at this and have a hard time factoring it. So my suggestion is to do a substitution. Okay, so this looks quadratic, so we treat it like a quadratic and we factor. And I'm going to add this in a second, but I want it in the interval from 0 to 2 pi. Okay, so I'm going to add in here. Zero to 2 pi. Okay. So how do we do this? So we can do a substitution. That might be helpful to us. You don't have to. Okay, if you can factor it without that, that's fine. But some of you may not recognize it right away. So what you do is you say, okay, let's let x equal the sine of theta. So you always choose this middle term, okay, whatever the trig function is. And if we do that, then what we get is 2x squared minus x minus 1 equals 0. And you solve that equation, okay? And this factors, I'm not going to go through the factoring with you because at this point you should be able to factor. Whatever method you use is fine. Okay, this factors to 2x plus 1, x minus 1, and again, you can use quadratic formula as well. You can use completing the square, although I think that would be a pain in this particular problem. Okay, so you get 2x plus 1 and x minus 1, and then substitute back. Okay. This is a theta. I wrote 0, but it's theta. So you can start by substituting. Then factor. Then substitute back. You don't have to do it this way. It's just if you have a hard time seeing it. So in other words, what it would look like. I'm not going to change the color, even though I prefer it or different. What it would look like is 2 sine theta plus 1 times sine theta minus 1 equals 0. So you can go straight from here to here if you want, okay? You don't have to do the substitution. The substitution is just there if it makes it easier for you to factor when you don't have the sine theta there, okay? Some of you will be able to do it, some of you won't. It doesn't matter what you do, okay? Then you're using the zero property. So then you have two equations that you're solving. You're solving 2 sine theta plus 1 equals 0. And then you have sine theta minus 1 equals 0. Okay, and we solve. So in this one, we subtract 1 from both sides. In this one, we're going to be adding 1 to both sides. So on this side, we get 2 sine theta equals negative 1. On this side, we get sine of theta is equal to 1. Over here, we have to do an extra step and say divide both sides by 2. So our final answer here is sine of theta equals negative 1/2. So now we just have to solve each of these separately. So let's take this one first. We have to think about what quadrants we're in. So the quadrants, sine is negative. So we're in quadrants 3 and 4. So this is where sine is negative. That's how we know which quadrants we're in. Okay. And what's our reference angle? Well, what angle has a sine of 1/2? 30 degrees. So our reference angle is pi over 6. Okay. So you can think about it as pi over 6. You could think about it as 30 degrees and then convert to radians. That's up to you. In quadrant 3, so notice we're writing theta equals. We're not writing x equals. That's because our original problem uses theta. Now, especially if you did the substitution, x would be incorrect. There is no x in this equation. Okay? So theta equals pi plus pi over 6 in quadrant 3. So pi is 6 pi over 6. So this is 7 pi over 6. So notice we do not write plus 2 pi n. That's because we have an interval here that says don't go past 2 pi. Okay. In quadrant 4, it's 2 pi minus pi over 6. So 2 pi here with a denominator of 6 is 12 pi over 6. So here we get 11 pi over 6. Sorry. Put my 11 in the wrong place. Okay. Sine of theta equals 1. Well, this is on the unit circle where the sine equals 1. This is where our y value equals 1, and there's only one place. There is no reference angle here, okay? It's on the axis. So on the axis, our theta is equal to pi over 2. So we have, if we just summarize here, we have theta equals pi over 2. We have theta equals 7 pi over 6. And we have theta equals 11 pi over 6. These are our answers to this problem. Okay, so we have 3 solutions. Sometimes you have 4 solutions. Let's take another one. Let's do a multiple angle equation. A multiple angle equation is a little bit different. Just in the very last step, okay? And we'll do this without an interval. So 2 cosine 3 theta minus 1 is equal to 0. So notice the difference here. It's not cosine theta. It's cosine 3 theta. Okay? Now everything is the same until the very end. Okay? So the very end is what changes. It only changes the very last step. Everything else we do exactly in the same way. Okay, so don't get rid of that 3. You leave that 3 until the very end. So we do the same thing that we would usually do. We isolate the trig function. So we're going to add 1 to both sides. That gives us 2 cosine 3 theta. Is equal to 1. Divide both sides by 2. That gives us cosine of 3 theta equals 1/2. Still, don't do anything about the 3 theta, okay? Think about what quadrants. Think of the 3 theta as like together, okay? It's grouped. So we're going to think about what quadrants we're in. The cosine is positive. Cosine is positive in quadrants 1 and in quadrant 4. These are the 2 things that we're looking at, okay? So that's how we come up with these. What's our reference angle? Well, the cosine, we're looking for where the cosine is equal to 1/2. So the cosine is equal to 1/2. The reference angle is pi over 3. So here's the difference, okay? We're not saying that theta is equal to, we're saying 3 theta is equal to. So in quadrant 1, 3 theta is just equal to pi over 3. And there's no interval, so we do 2 pi n. Okay? In quadrant 4, 3 theta is 2 pi. 2 pi minus pi over 3. Or 3 theta, 2 pi with a denominator of 3 is 6 pi. So it's 5 pi over 3. And then same thing, plus 2 pi n. Now we're not quite done yet, okay? We solve for 3 theta. And then to find theta, we just divide everything by 3. I'll fix that in a second. So we have 2 solutions, right? We have 3 theta is equal to pi over 3 plus 2 pi n. So dividing everything by 3 is the same thing by multiplying everything by 1/3. That might be an easier way of looking at it in terms of the simplification. Okay. You also have 3 theta is equal to 5 pi over 3 plus 2 pi n. So our last step is to cancel out the 3. So our last step is going to be multiplying everything by 1/3 to get rid of that 3. So it gets distributed to everything. It's the same thing as dividing by 3. It just might make the division by 3 for the 5 pi over 3 and pi over 3 a little bit clearer. Okay, so what's our final answer? Theta is equal to pi over 9. We're almost there. Plus 2 pi n over 3. Here, theta is equal to 5 pi over 9 plus 2 pi n over 3. So that's the extra step, that if you have a number before this theta, your extra step is just at the very end to get rid of that number. So here at the very end, we get rid of the number just by dividing everything by 3. We'll do 2 more, okay? 2 more, and then we'll finish up. So 8, let's do 2 sine of 2 theta minus square root of 3 is equal to 0. Okay, so we're going to solve this like any other equation. We isolate the trig function by adding square root of 3 to both sides. This might be a good time for you to pause and try it yourself. Okay. So we have 2 sine 2 theta is equal to square root of 3. Divide both sides by 2. So now we have sine of 2 theta is equal to square root of 3. Remember, it is equal to square root of 3 over 2. Remember, this 2 theta is not a square. Okay, 2 theta is not a square. So now we identify the quadrants. So we are in sine is positive. When sine is positive, we're looking at quadrant 1 and quadrant 2. And we have to find our reference angle. And our reference angle is pi over 6, is pi over 3. That's the sign where square root of 3 over 2. Okay. Quadrant 1. So it's not theta, it's 2 theta is equal to pi over 3 and then plus 2 pi n. Same thing here. It's not theta. It's 2 theta. So in quadrant 2, it's pi minus pi over 3. So pi minus pi over 3, that's 3 pi over 3 minus pi over 3 is 2 pi over 3. And then don't forget to add the 2 pi n. Okay, so how do we solve? We multiply, we get rid of the 2 by multiplying everything by 1/2, okay? Or dividing everything by 2. It's the same thing. Because we're not trying to find 2 theta, we're trying to find theta. So we distribute to everything. Okay, the multiplying by 1/2, again, I just do it that way so that it might be a little bit easier for you to look at your denominator here. So we get rid of the 2, we get pi over 6 plus 2 pi n over 2. This means theta is equal to pi over 6 plus pi n. This is 1. Remember, you want to reduce your fractions, so the 2's cancel here. Okay. Here, we get theta is equal to 2 pi. I wrote 2 equals. Don't know where that came from. Theta is equal to 2 pi over 6 plus 2 pi n over 2. So what do we get here? 2 pi over 6 becomes pi over 3. And then once again, plus pi n. So 2 solutions. Okay. So let's think about what we did. Okay. Once again, we isolate our trig function. We found the quadrants. Again, based on whether our trig function was positive or negative. We found the reference angle. Using that, we were able to solve for theta. So depending on the quadrant, you're either doing pi minus theta. Sorry, you're doing, I got confused. You're doing pi minus theta, pi plus theta, or 2 pi minus theta, and then, or just theta itself. That depends on the quadrant. That's what we talked about at the beginning. And then finally, you're, in this case, dividing everything by 2, or multiplying by 1/2. Same thing. That's for this case. For the last case, we multiplied everything by 1/3. Okay. One last one. Two tangent x over 2 minus 2 is equal to 0. So same thing. We're going to add 2 to both sides. So we get 2 tangent x over 2 is equal to 2. Divide everything by 2. Again, all you're doing is isolating the trig function. So this cancels, and we're left with tangent of x over 2 is equal to 1. Now you're going to feel obligated to get rid of this 2 now. You do not get rid of it now. As soon as you isolate your trig function, you solve, okay? So quadrants, tangent is positive. So where's tangent positive? We're in quadrant 1, and we are in quadrant 3. This is where tangent is positive. What is our reference angle? Well, our tangent is 1. It's the tangent of pi over 4. Okay? The sine and the cosine have to be the same if the tangent is 1. That's only true for 45 degrees for pi over 4. Okay, so in quadrant 1, x over 2 is just pi over 4, and then we add the 2 pi n because we did not give you an interval. In quadrant 3, our x is pi plus pi over 4. So notice I just do this first, and then once I add this, then I add in the 2 pi n. You don't have to do it that way. You can add the 2 pi n at the very beginning, okay? I do it that way just so that I am doing the addition first, and then I can just add in the 2 pi over n at the end, and I don't have to worry about it in the middle. But some of you may forget to do that, so that's why I would be a little bit nervous. But that's all personal preference. But your final answer has to have the 2 pi n in it, okay? So here we have 4 pi over 4 plus pi over 4. we get 5 pi over 4 plus 2 pi n. Okay? How do we get rid of this? How do we solve for x? Well, in this case, it's different. In this case, we're multiplying both sides by 2. And you're distributing to everything. So now we have our two answers. We have x equals 2 pi over 4 plus 4 pi n. Make sure that you reduce your fractions. This is your first solution. And if you have an interval, then obviously you just wouldn't have this 2 pi n, and your answer would just be pi over 2. Okay. Here, we get 10 pi. And I'm going to rewrite this down here too, because it's really this one that you're multiplying by 2. It's not this one. So here it's x equals 10 pi over 4 plus 4 pi n. And we reduce, so 5 pi over 2 plus 2 pi n. And if you go straight to the 5 pi over 2 plus 2 pi n, that's fine. Do not skip this step, okay? Don't go straight from, don't go straight to this, where you go straight from reference angle to this. Don't do that, because I'm not going to know where your answer came from. So again, this is all about communication. This is all about repetition. It's all about verifying answers. We can't verify your answer if we have no idea how you got to your answer. So you do need this intermediary step, okay? You have to have that, where you say x over 2 equals, okay? And this is it. So these are all of the different types of equations that you would be asked to solve. So you should become familiar with them. And that's it for trigonometry. That's it for the whole semester. Okay, so we are officially done. And if you have questions, email me. It's probably going to take me a second to stop the tape. So stop listening and looking now.